Welcome back, Wildcats. All right, so what we're doing today is looking at Monday, September 19th, graphing absolute value functions. Okay, and these notes are going to be on page 11. Okay, so please pause the video and update your table of contents. All right, now that you've updated your table of contents, let's go to page 11. All right, so let's update our notes on graphing absolute value functions. Okay, so a couple things. Let's just review some absolute value function information. Okay, first thing, absolute value by definition is the distance from zero. Okay, so that's the definition. What happens with absolute value is it makes the value positive. Okay, and the reason we say that is because the absolute value of -2 is 2, and the absolute value of 2 is 2. And the reason being is -2 is 2 from 0, and +2 is 2 from 0. Okay, so same distance, just one's negative, one's positive. Okay, now the parent function is f of x equals the absolute value of x, and so we can write parent function next to that. The domain of the parent function is all real numbers, and the range is y greater than or equal to 0. Okay. Now, because we're talking about transformations, I'm hoping now when you see this that you realize, oh, these notes are going to work for all the functions. Okay. So first off, just a reminder that the parent function is f of x equals the absolute value of x. These symbols right here mean absolute value. And so what I'm hoping you see is this is the same format we did with the other notes, except for instead of parentheses, these are now the absolute value bars. Okay. So still, when the negative is on the outside, it reflects over the x-axis. The a value outside of the absolute value, when greater than 1, is a vertical stretch. When that value is between 0 and 1, it's a vertical compression. Now, the negative on the inside of the absolute value in front of the x reflects over the y-axis. And the b value in front of the x inside the absolute value, when between 0 and 1, is a horizontal stretch. When greater than 1 is a horizontal compression. Okay? And then moving up, we have when it's plus h inside the absolute value, it's translate left, and when it's minus h, it's translate right. Now, when it's plus k on the outside, it translates up. When it's minus k, it translates down. Okay. Now, I know in some of the videos that sometimes things cut off, so what I'm going to do is I'm just going to slide the notes back up and down real quick just to make sure you get them, and then we'll move forward. And obviously, you can pause the video at any time to update. Okay, that should get you updated on all those notes. Okay, and remember, you need to refer back to this anytime you're looking at the transformation. So you look at the function and then say, okay, where does this work? Ah, it does this. Okay, all right, so let's move on to the example. Now, the examples are what I now understand is where some of the frustration. So let me try to clear this up in this video, and I'll try to remind you in every video. Okay, the notes, there shouldn't be any problem with you. Write them down, and then you can ask questions about those. So those are just writing the notes. Here's where I think some of the frustration might come from. Now, if you're watching this video, I want you to try these examples. If you get them, then keep going. Keep writing them down. If you don't, then you should look, oh, I'm going to put a question mark here. You know what? I'm going to stop on example 2. I don't get it. And then come to class and then say, Mr. Luke, I would like you to explain example 2. And then I will explain example 2. Okay? And so I want you to understand you get the best of both worlds. You get to see some of the lesson before you come to class, and then I can teach just like a regular class. So, but you have to let me know, right? Because if I say, hey, does anybody have a question on example 2? And nobody says anything, well, then I assume no one has any questions, so I move on. So you just, all it takes is one student, or you be that student, say, hey, Mr. Luke, please explain example 2. You can do that. Everyone, you say, Mr. Luke, please explain example 1. Please explain example 2. And I'll explain all the examples, okay? Just all you have to do is let me know. Okay, so again, I'm going to go over these examples. If you get it, great. If not, then just come to class and say, hey, I didn't get some of those examples, and I'd like you to explain it to them, okay? So it says graph the absolute value and state the transformation equation and the domain and range. So let's start by doing example 1. Example 1 is the parent function, okay? So we know that when x is 0, the absolute value is 0. So if we made a table, and I said 0 because 0 just seems like an easy number, but let's start at -2. So the absolute value of -2 equals 2. Okay, so I'm going to go to -2, up 1, 2. Okay, then when x is -1, I'm going to do the absolute value of -1, which we know the absolute value of -1 is 1. So that's -1, 1. And then we're going to do 0. So the absolute value of 0 is 0. So that's 0, 0. Then x is 1. So the absolute value of 1 equals 1. And then absolute value of 2 is 2. And so you could keep going, and you could actually graph it in your calculator, absolute value of x, and you get the table values. But the point of this isn't to do that. So the point is really to understand the transformation. But this is just the parent. All right. So the domain. So you look from left to right. And I'm going to put an LR just to remind. Okay. So from left to right, you know it doesn't stop in either direction. So the domain is all real numbers. Okay. Now the range is bottom to top. So we know it starts at 0. And we know that it's greater than, so we know the range is y greater than or equal to 0. All right, so when we talk about transformation, okay, the transformation is based on the parent function. So we're transforming it from the parent function. Okay, so we're transforming it from the parent function. Okay, so when we say here, we're going to say this transformation based on here. Okay, so let's start with that. So we know we're starting from here, but this plus 3, we know from our notes, is the plus k value. And we know plus k is a transformation up 3 units. So we know that we're taking this function and going up 1, 2, 3. So we start here because we know this function started here. And we know the transformation is up 3. So we go up 1, 2, 3. Okay. Now, you should know from basic algebra that the number in front of x is slope. And the slope is fraction. So the number in front of here isn't written. We know we can write a 1. And we know from a lesson that anything divided by itself is 1. So we know that 1 divided by 1 is 1. So this is okay. Okay. And since we know that slope is rise over run, so we know that this is slope is m, which is 1 over 1. We know that's rise over run. Okay. So the slope is 1 over 1. So we're going to go rise 1 to the right 1. 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 Okay. Now, what I want you to see is that the absolute value function is symmetrical, okay, and it has mirror points. So if you take this, the mirror points are here. So this is your mirror, okay? And I don't know, I'm watching in the video as I'm doing this, and I'm looking at it. That might be hard to see. So I'll write mirror up top here, okay? So this side right here, we can consider the mirror, okay? So here, okay, we have this side, we don't have the mirror. Well, the mirrors, so here, when we went up 1 to the right 1, the mirror is the opposite of that. So we go up 1 to the left 1. So here we went right, here we go left. So up 1 to the right 1, up 1 to the right 1, up 1. Whoop. In the video, you'll probably see that in the, I think they call it the closed captions. It's not right. It's up 1, left 1, up 1, left 1. I don't know where that right came in. Up 1 to the left 1, up 1 to the left 1. All right. Now, let's look at domain, okay? So domain, again, from left to right, okay? So we know it's all real numbers. Now range, from bottom to top, we see that it starts at 3, and we know it's greater than, so the range is y greater than or equal to 3. Now what I'm hoping you see is look at the domain and range for the example 1, and look at example 2. Absolute value will always have a domain of all real numbers, and the range will always be y greater than or equal to a number, okay? And so in this case, it was 0 because that's where it was. In this case, it's 3. So make sure you get the format correct when you're doing absolute value. Now the transformation. The only transformation we see is the plus 3, which you know is plus k, which we know the transformation is up 3 units. Now, I understand from our class discussion that y'all would like a little bit more in example. So let me make that adjustment now. So I've done before just 2 examples and said, hey, now try this. But as requested, and I listen to y'all, okay? Please understand that, okay? I'm not the teacher when you say things. I don't forget them. I remember what you say and I make those adjustments because I really want to do a good job for you. So to make that adjustment, I could do example 3, but example 3 doesn't have much going on, okay? Example 4 has more going on, okay? Now example 5 has probably the more complicated things, so I'll let you try this one, okay? But I'm going to give you a little bit more by giving you example 4 that should get you through example 3 and example 5, okay? So first things first, remember, we're starting from here. So we're going to start at 0, 0, and we're going to move the transformations from that, okay? So here, first things first, we're going to work inside the absolute value. So we know that the plus 3 inside is a translation left 3 student units. So we're going to take 0, and we're going to go left 1, 2, 3. And I'm going to kind of remember here because we're not done with the transformation. So I went left 3, but now we see that, because remember that's the plus h, but here we have minus k. So we went left 3, now we need to go down 3. So we went left 1, 2, 3, and then down 1, 2, 3. So there's our transformation point, okay? Now remember from example 2 that the number in front of x is slope. And I can divide any number by 1, it doesn't change things. So the slope here is negative 1 divided by 1, which we know is rise over run. Okay, so negative we know goes down, so we go down 1, positive 1 means right 1, so down 1 to the right 1, 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 down 1 to the right 1. Okay. Now, what I didn't say, and let me say in this point right here is the vertex, okay? In this problem, this was the vertex. And this point is the vertex. The vertex is the lowest or highest point. In this case, this is the lowest point, lowest point. In this case, it's going to be the highest point, okay? And the vertex in an absolute value splits the graph in half, okay? So now we know that this is the mirror image on the other side. And so to do that, we did go down 1 to the right 1. So the mirror of that would be down 1 to the left 1. So down 1 to the left 1, 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 down 1 to the left 1. And so then here is your transformed absolute value. Okay, so we know from all examples, we know the domain is all our numbers. Okay, now something slightly different. Here these have been greater than because they've been going up. Here this is going down, so it's going to be y less than or equal to. So still in the same format, but because it flipped, that changed. Okay, so sometimes that changed if the graph is reflected. Okay, and I should say flipped. It didn't flip, it's reflected. Okay, so we know it's y is less than or equal to negative 1, negative 2, negative 3. Okay, all right. So the last thing is transformation. So first thing is you look up the negative in front. So I'm looking at here. That's the negative value, negative in front of the absolute value symbol. So we know that this reflects over the x-axis. Okay, then we look at the plus 3, which we know is the plus h. So we know that that is left 3 units. And then the last is the minus k, so that's down 3 units. Okay? All right, so let me conclude with this. Okay? If you went through all of, you just watched the whole video and you didn't get anything, then stop, take a deep breath, so, and then realize, okay, and then close your Chromebook, and write some notes down and say, I want Mr. Luke to help me on example 4. I want Mr. Luke to help me on example number 1 and example number 2. And then when you come to class and you say, Mr. Luke, can you help me example 1? I'll be like, well, yes, I'll help you on example number 1. But if you get example 1, then we can move to example 2. So please understand that you weren't expected to get all of that. If you did, that is phenomenal. That's great. That gets you started. When you come to class, you can start working on examples and move fast into assignment. But if you didn't, then I can go into a conventional teaching style, like some of you are kind of concerned about, and then go over the examples. Okay, so you get the best of both worlds. Or you're so stressed out, I'm here in the morning. Come in and see me before school. Okay, or during lunch or after school. I'm here to help you. Okay, I'm a wildcat teacher that cares. Okay, and I'm here to help you. All you have to do is say those words. Say, "Hey, Miss Luke, I need help," and I got you. I'll help you. Okay. So with that, have a terrific wildcat night.